Hi and welcome to my second video about joining a mutable batch data frame with a streaming data frame. This time I will show you solutions that I tried to solve the issue presented in the previous video. And the first solution uses a temporary table. So in my temporary table, I will have a temporary view called timestamps to join, and I will also have a secondary thread that will refresh this view whenever I create a success file to indicate that there is something new that happened. So the join is very similar to the join from the previous demo, except that here I will use a data frame created directly from the SQL method. And of course I will use this global table. And you will see that it doesn't work simply because this temporary view is only a kind of virtual alias. Currently it doesn't copy any data to the data frame. It's only a kind of a table, a virtual table alias pointing to this data set, and I will try to show you that in the demo with some breakpoints. So I will just uncheck the delta breakpoints and I will keep these two app and running. So I will recreate the data with two files. If you remember correctly, I have here two files and here three files, and the difference is that these two first files are empty in the second generation. And now I will create the temporary view. I will run the temporary view up, sorry. So what happens for this part of the demo? One of two, just to recall. So we are starting by listing all the files, so creating the in-memory file index, which is used under the hood by Apache Spark file-based data source to find out what are the files composing the data frame. So you can see that I'm creating this index. So Spark creates this index from a file table data source. And here is the action currently listing all the files in the directory. So you can see that we have file1 and file2.json because we have run only the first data generator. And yes, that's all it's ready. And now when Spark reads the files, it uses this cache. And because of this cache, Apache Spark will not regenerate the data frame every time. So you can imagine that because of that, obviously we will not be able to see this extra file 3.json joined with the streaming data frame. So here yes, it's still the setup part. Now do we have something? No, not yet. Okay, so let me just show you that I will generate number 4, and you can see that to join we are using the data frame based on these already resolved files in the cache. And that we will print the correct join with the number 4, obviously because it's present in the file. Now I will do the same, but before joining I will regenerate the data set that we want to join. So here we should have 3 files. And as you can see, the previous action didn't come from the micro batch join, because if we skip this part, yes, if we skip this part, you will see that it currently came from this background thread that looks for the success file, and when the success file is there, it simply refreshes the timestamp to joins view, and you can see that we correctly integrated this file free.json, because in this show command we have all 4 rows from 10 to 16. So let me just maybe remove this file just to avoid recomputing every time. So okay, so now I will just click a few times more to validate this refresh. Okay, it's done. Yeah, it's done. And now I will send new data to join. So I will put 12 and 4 to show you that neither of them is in the file. Simply because, as you can see here, we are using the cache for the resolved files composing the batch data frame, and we still have this file1 and file2 JSONs files, and that's the reason why when you click on, you will see that the join will not happen neither for 12 and nor for the number 4, even though in this data frame we have the number 12 already, and still, even though we correctly refreshed the global timestamp to join temporary view. So that was for the case that didn't work. Hopefully you can overcome this refresh issue by using a different data format that in my case it's a Delta Lake format. So the code is very similar to the previous one. I have some batch data source that I'm reading as a Delta table, and I'm doing the join with Kafka with a structured streaming data frame. The code for the data is also similar. I have 4 rows each time, and yeah, this time I didn't create explicit files, but of course Delta Lake every time will generate a new file, it will not overwrite a new one. So normally if it would work as a JSON, I wouldn't be able to make a join between 10, 12, 14 and 16 from my batch data set, and with the same numbers coming from the structured streaming dataset. So let me show you that, and I will start by generating the version 1 of the Delta files. And this version 1 normally generates the numbers from 0 to 6, even numbers from in this range. So I'm starting from the latest. That's cool, and yeah, and I will run this app in the debug mode. So I will maybe just delete something from my demo list. Okay, sorry for disturbing. Yes, I can go back to the demo, and you can see that here we are creating the Delta table 2. We have the path, and if we click on, we will see that in a few seconds we should access to an index containing all files. Yeah, that's the moment. All files to include in this Delta Lake data frame. So the index will do some update just here, create a relation from this data set, and to update the index, here you can see that we are starting by finding what is the latest version of the Delta Lake written to our directory. So it will be snapshot version to use version 0, because we have only one writing action for our data set, and we are creating the relation. So yes, that's Yeah, the next step is to list all files for the corresponding version. So yeah, so that's it. We should have our first microbatch, that's correct. So now let me just add some values that will make the join with the batch data frame version 0. We are listing all the files to scan, and we should have the join just here. Now the second part, so I will generate new files. Remember, Delta Lake never overwrites the files with the same name. It always adds the new ones to the directory. So maybe just I will show you that. So you can see that we have so far, yeah, we have now one partition file per static data writer version. So it's already executed correctly, yes. And let me now do the action I have done before. So add the record from the previous data frame. So it will be 4, and from the new one, which will be 12. So what happens? Let's observe what happens here. So we are finding the matching files, and logically we should now find out that the Delta Lake was updated, so the version changed, and because of that we will list all the files corresponding to this version 1. And that's the reason why, we will see a correct join between the batch data frame between this new batch data frame and between the streaming data frame for the data that I just fill in Apache Kafka producer console. So that's mainly the reason why JSON data source will not be able to detect new files in the input directory. As you saw, under the hood, it uses a kind of index to, of course, accelerate the processing and the join, but on the other hand, it's also an inability to perform dynamic joins between changing batch data source and the streaming data source, versus Delta Lake that, as you saw before, always checks whether there is something new to expose in the data frame, and if it's the case, it will of course read the files, create a data frame with the content, with the new content, and perform the join with the structured streaming data frame, as you saw just here in this second part of the demo. So if you want to discover other parts, maybe also much more internals of these two aspects, I invite you to the article which is linked in the description of this video. It was Bartosz Konieczny from waitingforcode.com. Thanks for watching.